The moon has fascinated mankind since the earliest days of human history. It has played a central role in the making of annual calendars in Muslim, Jewish, and other cultures, and was considered one of the gods in many pagan traditions. Questions regarding the origin of the moon, its shape and composition gave rise to myths and legends that have accompanied humanity for thousands of years. And even today, many children ask themselves and their parents whether the moon is made of cheese. Up to this day, no model has been conclusive in explaining how the moon came about. But what has already been proposed and what is still missing? Let us take a look.
One early theory was that the moon is a sister world that formed in orbit around Earth as the Earth formed. This theory failed because it could not explain why the moon lacks iron, especially since the solar system is iron abundant.
A second early idea was that the moon formed somewhere else in the solar system where there was little iron, and then was captured into orbit around Earth. This failed when lunar rocks showed the same isotope composition as the Earth.
Currently, the most favored hypothesis for the moon's origin is a late-stage collision of the proto-Earth, i.e. early Earth, with a growing planet, often called Theia. This is the most favored hypothesis and is known as the least worst explanation for the moon's origin. This hypothesis came to be known as the giant impact hypothesis. In the most recent update to the hypothesis, it is suggested that instead of a glancing side blow, Theia likely collided into Earth with a head-on blast. In order to understand this, let us first lay down some background by comparing early models to more modern models.
$4.5 billion years ago, when planet Earth was just born, a Mars-sized protoplanet named Theia hit Earth in a side-glancing blow at a menacing speed of 18,000 kilometers an hour. That's 200 times faster than an airplane. Although Theia did not survive the crash and was crushed into pieces due to the massive impact, the Earth survived. However, the collision was too powerful that the Earth's axis was tilted by 23.5 degrees. The collision debris around the Earth's orbit quickly coalesced to form a spherical structure called the Moon, which is currently orbiting around the Earth. Now, if the Moon was created in this way, it will be composed of mostly Theia. With the advancement in science and technology, men began sending robots and even explored the space on their own in search for the truth. They collected rock samples from the Moon and Mars and brought them back to Earth to study the oxygen isotope compositions in these rocks. Oxygen has three isotopes, O16, O17, and O18, and its relative abundance can be denoted by the symbol delta. These rock samples from the Moon were chemically indistinguishable from those on Earth, while the rock samples from Mars differed to those on Earth by roughly 0.32 parts per thousand. Since both Earth and Mars are both formed in different places, the isotope signatures are different.
Likewise, if Theia and the Earth were formed in different places, the resultant moon, which is composed of mostly Theia, should be isotopically different from the Earth. These facts lead scientists to question the giant impact hypothesis. Remember previously when it was mentioned that recent news suggested a new model for the giant impact? Indeed, a paper just recently published in 2016 suggested that Theia collided head-on with Earth in a high-energy, high-angular momentum impact that resulted in vigorous mixing. This vigorous mixing between Earth and Theia would explain why the resulting Earth and Moon have indistinguishable isotope compositions. This finding further strengthens the ability of the giant impact hypothesis to explain the Moon's origin. Moving forward, scientists will need to continue refining comprehensive simulation models and geochemical analysis to elucidate new insights. So next time when your kids ask you if the moon is made of cheese, I'm sure you know the answer now.